Morning. Today we are going to discuss n element uniform array. So now in the previous classes we have discussed two element array. Today we are going to discuss n element array. Okay. We are going for n element uniform. So whenever there is a need of high gain atlas, okay, whenever there is a need of a high gain atlas, it is necessary to have a pattern with a single beam. It is necessary to have a pattern with a single beam radiation at high frequencies for point-to-point communication. Such a directive single beam pattern can be obtained by increasing the point sources from 2 to n. That's why you are going for n element array. So at higher frequencies for point-to-point communication, it is necessary to have a pattern with a single beam radiation. Such a high directive single beam pattern can be obtained by increasing the point sources from 2 to n. Okay. So let us study here the n element array. So here we have taken n number of elements. This is the first element, this is second element, this is third element, up to so on. So since I have started with 0, total number of elements are n minus. If I started with 1, my last element will be n. Okay. So, linear array. What is meant by the linear array? Linear array means all the antennas are separated by a distance t. All the antennas are separated by a distance t. What is meant by uniform linear array? All the elements are fed with the progressive phase shift. All the elements are fed with progressive phase shift. Then we call that array as uniform linear array. Okay, so let us take this point P, which is point of observation. Okay, so different signals will reach that point P after different times. Okay, so no doubt the element which is very nearer to the point of observation, the radiation will comes picture. So there will be path difference. So this is path difference. Okay, so total elements. Okay, so for each element there will be path difference. Okay, so now we'll calculate the total equivalent field R due to this all elements. What is the total electrical field we will obtain at point P? What is the total electrical field we will obtain at point P? Okay, so the total electrical field, the total field due to n elements due to n elements at point P. At point P is given as Et is equal to so each element here for this is fed with no phase, this is fed with, for example, let us take 30 degrees, next 60 degrees, next 90 degrees, next 180 degrees, like that. Progressive phase shift. We are providing progressive phase shift. Okay, so Et is equal to so all amplitudes are same. E0 into e to the power of J0 plus E1 into e to the power of J psi, sorry, E0 into e to the power of J psi plus E0 into e to the power of J psi plus E0 into e to the power of J psi plus so on E0 into e to the power of J n minus 1 psi. Okay, so this is the total electrical field. Okay, so therefore Et is equal to E0 plus E0 into e to the power of J psi plus E0 into the power of J psi plus so on into E0 into e to the power of J n minus 1 into psi. So let us consider this is equation 1. Now I am multiplying both sides with e power J psi. Okay, so what will happen? So multiply both sides with e power J psi. So what will happen? So first expression, Et into e to the power J psi is equal to E0 into to the power of J psi plus E0 into to the power of J psi plus E0 into to the power of 3 J psi. So what is the last one? J psi n get cancelled, you get e to the power of e into j n psi. Okay. So let us consider this is equation 2. Okay. Now subtract 1 minus 2. Subtract equation 1 minus 2. So this is equation 1. This is equation 2. Okay. So what you will get here? Equation 1 minus equation 2. Et minus et into the power of j psi is equal to. So see here, if I subtract here, this will both will get cancelled. E power j psi will get cancelled. This one will get cancelled. This one will get cancelled. Everything will get cancelled. But the final things will remain e naught minus e naught into the power of j n psi. Okay. So this is the final expression. If I take et common here, et common here, 1 minus e to the power of j psi is equal to, if I take e naught common here, 1 minus e power j n psi. Okay. So next, therefore, what is the expression from this? Et is equal to e naught into 1 minus e power j n psi by 1 minus e power j psi. Okay. So for example, e power a is there. I can write it as e power a as e power a by 2 into e power a by 2. E power a is there means I can write it as e power a by 2. The same model, et is equal to the same model. Et is equal to e naught into 1 minus e power j n psi by 2 into e power j n psi by 2 by 1 minus e power j psi by 2 into e to the power of j psi by 2. Okay. So e power x can be written as 1 by e power minus x. Okay. So this one and this one we can write in denominator. So et is equal to e naught into 1 minus e power j psi by 2 by e to the power of minus j psi by 2 by 1 minus e power j psi by 2 by e to the power of minus j psi by 2. Okay. So next. So if you write like this, and the next numerator, the final expression et is equal to e naught into e to the power of minus j n psi by 2 minus e to the power of j n psi by 2 by, similarly, e to the power of minus j psi by 2 minus e to the power of j psi by 2 to get e to the power of j n psi by 2 by e to the power of j psi by 2. Okay. So this is the expression. So what is the formula for e power e power j theta minus e power minus j theta is in terms of sign. Is in terms of, this is in terms of sign. This is in the form of like that. Okay, so final expression et is equal to minus 2j into e naught into minus 2j into sine n psi by 2 by minus 2j into sine psi by 2. Okay. Into, if I bring this numerator, it becomes j n minus 1 psi by 2. This one will get cancelled. Therefore, et is equal to sine, very, very important derivation, n psi by 2 by sine psi by 2 into e to the power of j n minus 1 psi by 2. Therefore, mod of et. So total electrical field due to n elements, it is equal to sine n psi by 2 by sine psi by 2. Very, very important equation. Okay. So sine n psi by 2 by sine psi by 2. So this is the standard expression for n element uniform array. N element